Chapter 4, Section 1 is about graphing equations in slope-intercept form. Now, last chapter, we did talk about slope-intercept form briefly when we started going over the different ways that we can graph equations. We talked about graphing equations with tables, with using the equation that they gave us in that slope-intercept form, and we also had talked about using the x and the y-intercepts to help us graph too. So we're going to focus more in this chapter specifically on the two main ways that you can think about the equation of a line, and one of those is slope-intercept form. Slope-intercept form, remember, looks like this right here, y equals mx plus b, where there's two really important pieces in that equation, the m, which represents your slope, and b, which represents your y-intercept. And when the y-intercept is useful for is kind of figuring out where your graph is going to start at. So you would go up 1 on the y-axis and draw a point, and then you could use your slope of up 2 and over 1, because again, you think of slope as a fraction, to get to your new point. Now, sometimes in an equation, they may not have it written in slope-intercept form. So if you're trying to graph a line using the equation like this, the first thing that you're going to want to do is solve the equation for y if it's not already done for you. So if they don't have it in that y equals form, you're going to have to get your equation in that form first. Then you're going to graph the y-intercept. So starting with that b point, you're going to either go up or down on your y-axis. Then you're going to want to look at your slope, change it to a fraction if you need to. So sometimes if it's a whole number, we just put that over 1. We don't want to have mixed numbers as our slope. We always want it to just be a single fraction. So you might have to rewrite it so that it's in that improper form. And then using the slope, go from your y-intercept point that you've already graphed. You use that rise over run method to figure out how much up or down and left or right you're going to go to get another point for your line. So let's take a look at this example I have here. They want us to graph 3x plus 2y equals 10. Now remember, we want to get our equations in this form. Y equals mx plus b. So I need to get y alone, which right now it's not, so I need to rewrite this equation so that I get my y by itself. So remember, when you're doing this, kind of think about if you cover up the 2y term right now, you need to move that 3x term first. Since it's positive 3x, to move it to the other side, we would subtract 3x. So when you subtract 3x, the ones over here on the left are going to be gone. You're going to bring down that 2y, bring down the equal sign, and then we have negative 3x plus 10. Remember, you cannot combine the 3x and the 10 because 10 doesn't have an x, so you have to keep them separate. And I would start getting in the habit of putting the x term first because you want your equation to look like this form. And they always put the mx term before the b. So the number with the variable needs to go first. That's why I put the negative 3x first, and then plus 10. Then what we're going to do is get y by itself. And to do that, we're going to divide by a 2, because right now this is 2 times y. Now when you divide by 2, you will need to divide everything over here by 2. So the negative 3x needs to be divided by 2, and the 10. To simplify this, over on the left, those 2's are going to cancel off, and you've got y equals. Now for that mx term, you've got negative 3x trying to divide by 2. I would not try to rewrite this as a decimal, because remember, we want our slope to be as a fraction so that we can graph it. So I would just leave this as negative 3 over 2, so leave the fraction, and I just put the x next to it. Then I've got 10 divided by 2, which would simplify to a 5. Now this looks like our slope-intercept form. It says y equals your mx plus b. So b would be 5, and that negative 3 over 2 would be your m, your slope. So now what we need to do is graph this line. So in order for you to graph, you always start with your b, which is the 5. So from 0, 0, you're going to count up 1, 2, 3, 4, 5, and draw a point. And your slope is -3 over 2. That negative sign only applies to one of the numbers, so either the 3 or the 2, but not both. So if it's -3 that you're thinking, from that point that we just graphed up here at 5, you need to go down 3, and then 2 is positive, so that means you go right 2. So from that 5, I went down 1, 2, 3, and I went right 1, 2. And you could do that again if you wanted to. You could go down 1, 2, 3, and right 2 to get another point for your line. Once you've got a couple of points, and really you only need 2, but you can always graph more than that if you wish, you need to then grab a straight edge, just like we were using like your lunch card in that last chapter. We're going to do the same thing here. And we're going to connect our dots. Again, remember, lines go on forever in both directions, so make sure that you extend that line through the points and you draw arrows on both sides. So there's a couple of practice problems on this next page. What I want you to do here is take some time to work through these. So you'll need to rewrite them for the y first, and then be able to identify your slope in your b, and then I want you to graph the line. So take a few minutes to try to do each practice problem individually. If you need to kind of come back and watch how I did this one before you move on to the second practice problem, you can do that. So for this first one, I'm going to start by subtracting x. So we would have -2y equals -x plus 12. Again, get in the habit of putting x first. Then I divided every term by -2. So I have y equals, this would be -1 over -2. A negative over a negative is going to make that become positive, so I write that as +1/2 x. And then 12 divided by -2 would be -6. So there's your equation. Now the -6 is your b, and the 1/2 is going to be your slope, your m. So to graph this one, you should have started by going down 6 because it's -6 for your b. And your slope is 1 over 2. So from -6, you should go up 1, right 2. Up 1, right 2. Okay, so here's the second practice problem. If you haven't given this one a try, I would go ahead and take a minute or two and try to do this one on your own before you continue watching this. So again, I need to start by trying to solve for y first. So I'm going to subtract 6x from both sides. So we have 2y equals -6x plus 5. Then we're going to divide by 2. So this should say y equals -6 divided by 2 would be -3x, and then plus 5 over 2. Now when it came to graphing this one, your b is a fraction. So what I would have done is thought about this as a decimal just for graphing purposes to get your first starting point. So this would be the same thing as 2.5. which means that on my graph over here, I'm going to go up 2 and about a half, and I'm just going to roughly guess where I think that would be and draw my first point. Now my slope is this -3, which would be -3 over a 1 if I wrote that as a fraction. So from 2.5, I'm going to go down 3 and right 1. Down 3 more and right 1 again. Now all of those points are going to be halfway between squares because my starting point was halfway between squares on the y-axis. And then we draw the line. Again, make sure that you've got arrows going on both sides of that line there. All right, let's take a look at these next two examples together. Now, these ones are kind of those special cases, and we did see these show up again last chapter when we were going over the different types of slope. We talked about positive slope, negative slope, and then we talked about zero slope and undefined slope. And that's when you're going to see these types of equations. Something to think about for this first one, because it just says y equals 2. I want you to think that because it only says y, there's no x term. There's no x in this equation, which means that this graph can't cross the x-axis. So if I'm looking at the coordinate plane here, remember that your x-axis is the one that goes left to right, the horizontal line, and your y-axis is the one that goes up and down. So if I'm going to graph y equals 2, I would go up 2 on the y, which would be like right there, and it cannot cross the x-axis. So it should not be a line that goes up and down because that would go through the x-axis. Instead, it should be a line that lays flat and goes through that point y equals 2. Now, if it says x equals a number instead, similar case, but think of it as there's no y for this one. So it can't cross the y-axis. So for this one, you would go -1 on the x-axis, which would be right there, and it can't cross the y, so I don't want it to be a flat line. Instead, I want it to be a line that goes straight up and down, like that. So anytime that you see these types of equations that have just a y or just an x, think about those kind of reminders. They're not necessarily rules. They're just kind of a way for you to maybe think about what the line should look like before you even go to graph it. All right, let's take a look at this next problem, which is a story problem here. So the Band Boosters are selling subs for $5 each. They bought $1,160 worth of ingredients. There's a couple parts to this. They want us to write an equation to represent the profit. They want us to graph the equation, and then they want us to find the profit if they sell 1,400 subs. So to write our equation, we're still using that slope-intercept form, so y equals mx plus b. We're going to put in the information that they gave us here, the $5 and this $1,160 in for pieces here. Now we need to think about kind of which is which piece, like, because we got to put in something for M and something in for B. Now each sandwich that they sell is $5. So if they sold one sandwich, they're going to earn $5. If they sold 2 sandwiches, they're going to earn $10. If they sold 100 sandwiches, they would earn $500. Now, how I'm doing that is I'm taking 5 times the number of sandwiches that they sell, which would be represented by X in this equation, because that could be changing. If they sell 2 sandwiches, 100 sandwiches, 200 sandwiches. So for this problem, I'm going to put in 5 for the M. 5 is your slope. So 5x. Now that $1,160, that's for the ingredients. They've already spent that money. So that's not additional money that they're taking in. That would be money that they have spent. If you're spending money, that would be negative. So instead of writing plus B plus that 1,160, we're going to write minus 1,160 because they have already spent that much money. So this would be your equation. Now, part B wants us to graph this. Now, last chapter we saw some problems where we had to graph a situation, and the graph that we had provided for us wasn't really ideal for what we were given. So I want us to change the graph so that it fits my points a little bit better here. Okay, so I'm going to change both my x and my y-axis. I'm going to have my x-axis go by 100ths. Okay, so what that means is down here, this first one's going to be 100, and then 200, 300, and so on. Now my y-axis, I'm going to have go by 500ths. I'm also going to include some negatives because my b is a negative number for this problem. Okay, so to graph this, we can start with that b, which is negative 1,160. Now you'll have to estimate where you think that is. So you got to go down to that negative 1,000, go a little bit over that, and draw your first point for that b. Now my slope right now is 5 over 1. That would be really hard for me to do on this graph because I changed my scale to go by 500ths and to go by 100ths. So if I were to just move this up 5 over 1, up 5 over 1, I really wouldn't be able to see where those points are at because my graph really isn't designed to handle such small numbers right now. So instead, what I want you guys to think about, when you have a slope like this, if I wanted to change the scale of my slope to better fit my graph, I can. To do that, you just need to multiply both the numbers by the same number. So I'm going to take both of these times 100. So I'm going to think of my new slope as 500 over 100. So instead of going up 5 over 1, up 5 over 1, I'm actually going to go up 500 over 100. And that should give me a little bit better access to my graph of being able to put those points on there because they're going to fit better with my scale. Really, the important thing is that you're just trying to do the best you can with estimating where those points are going to be. We do not expect these to necessarily be perfect because the numbers are so large, but that is what the graph would look like. Now, part C wants us to figure out what the profit would be if they sell 1,400 subs. Well, the number of subs that they're selling would be your X value. So this 1,400 is an X. So in my equation here, I'm going to take 5 times 1,400 and then subtract that 1,160. And if I evaluate that, I should get $5,840. So that's how much they would make if they sold 1,400 sandwiches. The last thing I want to talk about in this section is if they give you some information about the graph, they want you to be able to write the equation, and then we should still be able to graph it like we have been graphing it previously. So these last ones are going to give you what the slope of the line would be and what the y-intercept would be. So remember that your slope would be your m value, your y-intercept would be your b value. So using that equation, y equals mx plus b, we're going to put in the m and the b. So this is going to say y equals 1/5, goes in for m, so 1/5 x And then instead of plus b, we're going to write minus 3 because b is a negative number. So I don't need you to write like plus a negative 3. Clean it up. You only need one sign separating your terms. So that's why I'm just writing minus 3. Then I can graph this. So you start down on the y-axis, 3 points for that minus 3. Then you're going to go up 1 and over 5. So I want you guys to try to do the practice problem here. So remember that negative 3/4 would be your m because that's the slope. The 5 would be your b because that's the y-intercept. So my equation should have said y equals negative 3/4 x plus 5. To graph it, you should have started by going up 1, 2, 3, 4, 5. And then your slope is down 3, right 4.